Welcome back to the deep dive. You know, if you've spent any time in software development over, say, the last couple of decades, you definitely know the hierarchy. It was sometimes unspoken, sometimes, well, shouted across the room. Code was king, always.
Absolutely. And specifications. They felt like temporary scaffolding, didn't they?
Totally. Documents you'd build, maybe argue about for a bit in a meeting, and then, honestly, often happily forget about them or just let them get completely out of sync once the real work of coding started.
They were brittle, often outdated almost immediately, right?
Yeah.
Before the first feature was even really done.
Exactly. Historically, specs were just passive guides, sure, but not active parts of the actual system being built. They were the ideal, maybe, while the code was the messy reality.
The spec was the plan, the code was the product, and if there was a conflict, code always won. No contest.
But today, we're diving deep into a world where that whole script is being flipped, completely flipped. We're looking at Spec-Driven Development, SDD, and specifically this really powerful toolkit GitHub released to make it happen, the Spec-Kit.
And this isn't just some, academic thing or a tiny experiment.
No way. We're talking about a GitHub repo with, 27.9 thousand stars and 2.3 thousand forks. That's massive interest right out of the gate. It signals people are really looking for this kind of shift.
So that kind of uptake, yeah, it tells you developers are really feeling the pain of specs just dying on the vine. They're hungry for something better.
So what does the Spec-Kit actually do that's so different?
It's profound, really. It doesn't just treat specs like passive documents. It makes them executable. They become the direct input that actually generates the working code.
Wow. Okay.
So the whole focus shifts. Organizations can put their energy into really nailing down the product scenarios, the user intent, instead of burning resources on, the same old undifferentiated coding tasks again and again.
Okay, so that's our mission for this deep dive then. We want to go beyond just listing features. We need to break down the structure, the philosophy behind it, and the actual step-by-step workflow this kit uses.
Right. How does it manage to bring these super advanced, sometimes kind of abstract AI agents into a really structured, auditable development process?
Yeah, how does the prompt stop being just a suggestion and become like the enforceable foundation for the entire code base? That's what we need to unpack.
Okay, so to really get the value here, you have to start with a philosophical shift. It's fundamental. We're moving specs from being passive documentation like that Word doc buried on a wiki somewhere.
Which guilty, we've all seen this.
To being active code-generating inputs. Think about it like this. A traditional blueprint guides a carpenter, right? But a 3D printer file, that is the build instruction.
Okay. Good analogy.
If you change one line in that 3D file, the final object changes immediately, accurately. That's the kind of shift we're talking about.
That move from passive guide to active input feels critical because traditionally, if the code drifted away from the spec, maybe during a rushed sprint or something, the code just became the source of truth, and the spec was instantly outdated. But now you're saying the specification is primary. It holds the ultimate authority.
That's the idea.
But doesn't that risk creating massive bureaucracy? How does SDD make sure this new, richer spec doesn't just become another piece of ignored paperwork?
That's exactly where the Spec-Kit methodology comes in. It formalizes the whole thing around these 4 key philosophical pillars. They structure the entire way you interact with the AI agent, making sure there's governance.
Okay, pillar 1.
First up, intent-driven development. You absolutely must define the user outcome, the business goal, before you even think about the how, the implementation details.
So focusing on the business value first, it stops teams from, say, picking the cool new database and then trying to force the requirements to fit it.
Precisely. Avoids those premature technical decisions. Intent drives technology, not the other way around. That's pillar 1.
Got it. Pillar 2.
Pillar 2 is rich specification creation. And this isn't just writing down a few bullet points. It really demands using organizational principles, guardrails, which the toolkit actually calls the Constitution.
The Constitution. Okay, tell me more about that.
It's basically a document that lays out the non-negotiable rules for the project, the foundational agreement, if you like. And the AI agent has to stick to it throughout the entire project.
Okay, hold on. Let's pause on that Constitution idea. That sounds like where the real deep dive tech part comes in. Philosophically, I get it. But how? How does the AI agent running through a CLI actually adhere to this document? Does it just read it once in the start?
That's a great question. And it's crucial. It's the technical magic, really. That file, the .specify memory constitution.md, it isn't just a memo filed away somewhere.
Right.
It gets actively injected or referenced. Now, depending on the specific AI agent you're using, some have huge context windows, others use techniques like REJ, retrieval augmented generation, that constitution effectively becomes a permanent fixture in the AI system prompt, or maybe part of its working memory for every single command that follows.
Ah, so it's always there, contextually.
Pretty much. When you ask the agent to write code or generate a plan, the rules in the Constitution, things like all APIs must be RESTful or must meet level 2 security standards, they're constantly being factored into the output. It's the agent's ultimate rulebook.
Okay, that continuous adherence, that's the key. It turns governance from just a suggestion into an actual computational constraint.
Exactly. That's the power. Now, Pillar 3 tackles the reality and, frankly, the limits of today's AI tools. Multi-step refinement. Meaning SDD deliberately avoids that temptation of the one-shot generation. Where you dump a massive prompt with all your requirements and just say, build me the app.
Yeah, we've all tried that, right? It never quite works.
It fails. Because the AI gets overloaded, it starts hallucinating. It can't track all the interconnected pieces at once.
I've definitely seen that. It builds the first couple of files perfectly, then completely forgets the database connection by file 3.
Right. So SDD forces structure onto that inherently messy generative process. It demands this mandatory multi-step back and forth. Clarification first, then detailed planning, then auditing the plan, and only then do you execute.
Breaking the big problem down into smaller, verifiable chunks.
Exactly. Digestible pieces. And the final pillar, number 4, kind of underpins everything. Heavy reliance on AI. This whole structured process only works because we're using advanced, often specialized AI models. They need capabilities for complex interpretation, detailed planning, and that structured step-by-step execution.
So not just any chatbot off the shelf. You need a dedicated, code-savvy agent.
You really do. And this whole structure, this isn't just for building little demo apps. You need to understand this applies across the entire software lifecycle. There are 3 main phases where SDD really adds value.
Okay, let's talk about those. The first one's the exciting one, right? Starting from scratch.
That's 0 to 1 development, yeah. Greenfield projects. This is where you use the system to its absolute fullest. You go from those high-level requirements, the intent, all the way through detailed specs, planning every step, and finally generating production-ready apps.
Cutting down that time from idea to deployed code significantly.
Massively. The second phase really shows the power of the spec being the master document. Creative exploration.
Creative exploration, how does that work?
This is fascinating. It lets you generate parallel implementations. Imagine you've got one really solid spec for a back-end system, but you want to explore options.
Okay.
You could use that exact same spec to generate one version using, say, Python and Django, and another using Node.js and Nest.js, or even try out different UI patterns.
All from the same core spec.
Exactly. The spec is the constant.
Yeah.
The implementation becomes the variable you can play with.
That's powerful for comparing tech choices. And the third phase?
The third is the reality for most big organizations. Iterative enhancement or brownfield work, modernizing legacy systems.
Right, the stuff most developers actually spend their time on.
Absolutely essential. SDD helps here too. You can apply the whole structured workflow to an existing code base. Add new features incrementally, adapt things. It ensures that any new feature not only meets its own spec, but also still follows the rules in the Constitution and fits with the existing code's principles.
So it's not just a toy for new apps. It becomes a tool for governance, maintenance, modernization. That's crucial for enterprise adoption, I imagine.
It really is. That context shift is vital if you're thinking about rolling this out organization-wide.
Okay, philosophy covered. Makes sense. Now let's get practical. How do we actually start using this? What are the mechanics?
Right. The entry point is the command line tool.
Yeah.
Or Specify CLI. That's the foundation. You use it to bootstrap a new project, set up the right directory structure, and inject all the scripts and templates and stuff the AI agent needs to function within this framework.
So it's the glue that connects your chosen AI agent to the SDD process locally.
Pretty much, yeah. It's the operational layer. Without that CLI setup, your AI agent is just, well, a smart chatbot. With it, it becomes a structured development partner.
Okay, so before we even run Specify in it, what do we need? Prerequisites.
Yep, got to check the basics. It's designed for Linux or Mac OS primarily. But the docs explicitly say it works well on WSL2 on Windows, so Windows devs aren't left out.
Good to know. Software requirements.
You do Python 3.11 or newer.
Yeah.
Standard stuff. Git. And, importantly, the modern package manager, UV.
Okay, UV. Why U specifically instead of something like pip? Does that matter in an AI workflow?
It does, actually. That's a great point. It's all about speed and determinism. UV is written in Rust. It's incredibly fast compared to older Python tools.
Right.
In a system that's highly automated, where the AI might be rapidly creating environments, resolving complex dependencies, maybe installing temporary packages on the fly, that speed from UV becomes really important.
You don't want the AI just sitting there waiting for dependencies to resolve.
Exactly. You want near instant execution. .uv helps deliver that.
Makes sense. And the biggest prerequisite, I guess.
The elephant in the room.
Yeah.
The AI coding agent itself. This whole thing leans heavily on advanced LLMs, often specialized ones. The docs list a whole bunch of supported agents, which shows they're aiming for flexibility.
Yeah, I saw that list. It's pretty extensive. You've got the big names, Claude Code, GitHub Copilot, Gemini CLI.
Right, the enterprise players.
But also more niche ones like Cursor, Quen Code, Open Code, Windsurf, Kilo Code, Augie CLI, Roo Code. They've clearly put effort into supporting different environments.
They really have. But there's a key technical note in there, the older Codex CLI. It is supported, but
There's a catch.
yeah, the functionality is limited. Apparently, it doesn't support the custom arguments needed for those specialized /commands like constitution or plan.
So if you use Codex, you lose the fine-grained control that really defines the SDD process.
Pretty much. That alone probably steers most users towards the more modern, fully supported agents.
Okay, so assuming we have UF, how do we install the Specify CLI itself?
It's actually pretty clean, thanks to Yuva. Two main options documented. Depends if you want it installed permanently or just for a quick try.
What's the recommended way?
Option 1, the persistent install. Use uvalve tool install. This puts the tool right in your system path, making it easy to use.
And the command pulls directly from GitHub.
Yep. It's uvad tool install specify CLI from Git, plus https://github spec-kit.git. A bit verbose, but gets the latest code.
And the advantages of doing it this way.
Well, the specify command is just available everywhere, no weird aliases needed. Plus, managing and checking versions, upgrading, uninstalling, it's all handled neatly by UVev's own tool commands. Fits nicely into a standard setup.
But if you just want to test it out, or prefer not to install globally.
Option 2 uses UVX. It basically downloads and runs the tool temporarily without installing it permanently.
So the command would be something like gvx from git plus https://github.com, github spec-kit.git, specify init your project name.
Exactly. Specify init project name. It's flexible, caters to different preferences.
Okay, so either way, we now have access to the specify command. First step is initializing a project, right?
Right. The core command is specify init, usually followed by the name you want for your project. This kicks things off, pulls down the latest template, creates the basic directory structure.
Can you customize that initialization? Like, tell it which AI you're using or what OS you're on?
Absolutely. There were some key options for init. AI agent is crucial. You tell it explicitly. AI, Claude, or a Copilot, or a Windsurf, whatever you're using.
And I saw script ships. That looks important for Windows users.
Very important. It tells the kit whether the AI should generate standard shell scripts for Linux, macOS, or PowerShell scripts for Windows, especially if you're using WSL or PowerShell directly. Manages those OS differences for the automated parts.
Handy. Any other useful flags?
There's here. Or just using a dot as the argument. That initializes the project right in the current directory instead of creating a new subfolder. And if you are initializing in a directory that already has stuff in it, you might need force. It tells the tool to just go ahead and overwrite or merge files without asking. Dangerous, maybe, but useful for quick iteration.
Use with caution. Got it. Anything else before we dive into the actual development workflow?
One last thing. You can always run specify check. It's a simple command to verify your setup, checks for Git, the right Python version you buy EV, and make sure it can find your chosen AI agent CLI, like Claude or Gemini.
A quick sanity check before letting the AI loose. Good idea. All right, now we're getting to the core of it. We've initialized the project, the AI agent is hooked in. Now what? How does it actually work?
This is where those specialized /commands come into play. Constitution, specify, clarify, plan, implement. They provide the structure.
So the AI isn't just taking free-form text prompts anymore?
No, not for the core workflow. These commands force it into a highly structured, controlled environment. It's the mechanism that makes the whole process governed, auditable, repeatable. Stops the AI just defaulting back to being a generic chatbot.
Okay, this structure sounds like the real value proposition. Walk me through it. What are the steps?
It's basically a 6-step sequential process. A formalized pipeline, guided by the human developer.
Step 1.
Step 1. Establish principles with constitution. And this isn't optional. It's the mandatory starting point. The goal here is simple. Define the project's governing principles, quality standards, development guidelines before you even think about writing feature code.
What kind of stuff goes in this constitution? Is it just high-level philosophy or actual technical rules?
It needs to be both, and it needs detail. You put in things like security rules, no hard-coded secrets, use environment variables only, or architectural constraints. All data access must use an ORM, no raw SQL without explicit approval in the plan.
So you'd prompt it something like, Constitution. Define principles for top code quality, 90% test coverage, material design UX consistency, and sub 100 meters P95 latency. Also include rules for dependency choices.
Exactly like that. A detailed prompt setting the ground rules. And the key output is that specify memory constitution.md file. As we discussed, this isn't just a note. It's the AI's constant reference point, the non-negotiable rules of the game.
Okay, constitution established. What's next? Step 2.
Step 2, create the spec using Specify. Now we define the actual product. What are we building? And the absolute crucial rule here, enforced by the workflow, is be explicit about the what and the why, and deliberately avoid talking about the tech stack or implementation details yet.
No mentioning React or Blazor or specific databases here?
Nope. If you do that, you're jumping ahead and you lose the whole intent-driven benefit. Focus purely on the functional requirements.
Okay, let's use their example. Taskify, the team productivity tool. How would we spec that out?
You'd tell the AI exactly what users should be able to do. Create projects, assign tasks, add comments, drag and drop cards on a Kanban board. All the user-facing functionality.
But you need specifics, right? Not just a Kanban board.
Absolutely. Specificity is key to avoid AI guesswork. For Taskify, the spec needs to detail the user's setup, predefined users, maybe 1 PM, 4 engineers, and crucially, how they access it initially. No login password needed at first, just click a user's name.
And fine-grained constraints, too, like the Kanban board needs specific columns to do in progress, etc.
Yes, and even UI details like task cards assigned to the current user should show up in light blue. That kind of visual cue for prioritization.
What about interactions, like commenting?
Got to nail those down too. For instance, users can only edit or delete their own comments and only within 5 minutes, cannot touch anyone else's comments. That level of detail covers usability and security right in the spec.
And the output of Specify.
It creates a new Git branch specifically for this feature, like 001 create Taskify, and it generates the detailed spec file itself. Specs 001 create Taskify spec.md.
Okay, spec created. What's step 3?
Step 3, functional clarification using Clarify. Now, the documentation stresses this is mandatory before you generate a technical plan.
Wait, mandatory? If the spec is so detailed, why can't the AI just figure out the plan? Feels like extra friction.
It might seem like it, but it's a trade-off. This step dramatically reduces rework later, which is where huge amounts of time get wasted in traditional development.
How so?
It tackles the ambiguities that always remain, even in a rich spec. AI agents are great at generating stuff, but they're often bad at realizing when they don't fully understand something. Clarify forces a structured Q&A.
Structured Q&A, what does that look like?
The AI uses the spec.md and systematically asks you questions to make sure it covers every functional requirement. They call it coverage-based questioning.
Coverage-based. Okay, give me an example.
So, if the spec mentions sample data, the AI might ask, clarify. For the sample data, should projects have a fixed number of tasks or variable? Should they all start in to do?
Forcing you to add detail you might have missed.
Exactly. And you'd refine it. Ensure sample projects have 5-15 tasks each, randomly spread across all completion stages with at least one task in each stage. That makes the generated sample app way more useful.
And this is also where you validate acceptance criteria.
Yes. The last part of Clarify is prompting the AI to go through the review and acceptance checklist in the spec. It confirms which points are fully understood and covered, and flags any that still need technical decisions later in the planning phase. Forces functional sign-off before you talk tech.
Okay, clarified. Now we can talk tech.
Now we talk tech.
Yeah.
Step 4, generate the plan using plan. This is the pivot. Intent established, ambiguities resolved. Now you introduce the technical requirements, the desired stack, using the plan command.
Finally, so for Taskify, we'd say something like plan. Build this with .NET Aspire, use Postgres for the database, front-end must be Blazor server for real-time drag and drop, structure it with REST microservices for projects, tasks, notifications.
Precisely that level of technical direction. And the output here isn't just one file, it's a whole set of implementation blueprints.
Like what?
You get things like an apaspec.json, a detailed data model.md showing the database schema, the main step-by-step guide in plan.md, and potentially a research.md if the AI needed to look up complex stuff.
Okay, that research.md touches on something the docs highlight: handling rapid change. Frameworks like .NET Aspire change constantly. What if the AI's knowledge is out of date?
That's a huge challenge, right? The structured plan helps manage it. You have to prompt the agent to specifically identify areas where its knowledge might be shaky.
Oh.
You break down the research into targeted questions. Instead of just asking, how does .NET Aspire work, you ask, plan. Research the current best practice for Blazor server real-time updates within Aspire, ensuring it works with the Postgres health check. Very specific.
So the targeted research makes research.md more accurate, which then feeds back into a better plan.md. Clever way to handle the knowledge gap.
It really is. But there's a warning here we absolutely have to mention. AI agents can be, well, overeager.
Meaning they add stuff you didn't ask for?
Yeah, they might throw in complex libraries, extra microservices, overly fancy design patterns, just because they saw them in their training data. During this planning step, the human must prompt the agent. Plan, why did you include this caching layer? Show me where the spec requires it.
Ah, challenging the AI.
If the rationale doesn't trace back to the spec.md or the constitution.md, you tell the agent to remove it. Keep it lean and focused on the requirements.
Okay, plan generated, maybe trimmed down a bit. What's step 5?
Step 5, validation and auditing. Before you let the AI write any code, this rigorous audit is mandatory. It's the final human checkpoint. You prompt the AI to basically review its own work.
The AI audits itself. How?
You prompt it to read through its generated plan.md and all the related detail files, ap-spec.json, datamodel.md. You ask it to check for missing pieces, ensure the steps are logical, verify internal consistency.
So, like, audit review the plan and detail files. Is the task sequence logical? Do tasks reference the right details? Any dependency loops or missing steps?
Exactly that kind of prompt, making sure the plan is actually coherent and executable.
And you'd also double-check against the Constitution here.
Absolutely critical. You prompt.audit. Does this plan fully adhere to all rules in constitution.md? This is also where you force the agent to fix any over-engineering identified earlier. If it added something complex that violates the simplicity rule of the Constitution, you make it simplify the plan now.
Final checks. Got it. And then optionally create a pull request for tracking.
Yeah, if you have the GitHub CLI installed, you can have it wrap this up in a PR for review or tracking purposes.
Okay, Constitution, spec, clarification, plan, audit. We're finally ready for code?
Finally, step 6, implementation using implement. Preparation's over. Time to execute.
What happens here?
The implement command kicks it off. The AI first validates everything's ready, Constitution exists, spec is there, plan is done, and there's a tasks.md file breaking down the work. Then it just starts executing the tasks from tasks.md one by one, respecting dependencies.
Does it just generate code files?
It generates code files, but it can also run commands. If the plan called for test-driven development, TDD, it might generate a failing test first, run it, then generate the code to make it pass, run the test again, following the plan precisely.
Oh, okay, hold on. This is where that massive warning from the docs comes in, right? The AI is running commands on my machine.
That is the single most critical operational warning. Underline it, bold it, whatever. This is not a sandbox. The AI agent executes local CLI commands directly.
Like .NET build, npm install, database migrations.
All of it. Which means your machine must have all those tools installed, configured, maybe even authenticated correctly. If the plan says npm install and you don't have node or npm installed,
the implementation just fails.
Right there. The AI is orchestrating your local environment. It's not running code magically in the cloud. You have to provide the tooling.
Okay, super important caveat. What happens when things go wrong after implementation? Like the code builds, but the app crashes when you run it. Maybe a browser error the AI can't see in the terminal.
Good question. The process shifts into debugging mode. You, the human, copy and paste that runtime error, the browser console log, the server stack trace, whatever it is, and feed it back to the AI agent as the next prompt.
Ah, so the error becomes the new input.
Exactly. The agent treats that external error message as its instruction. It analyzes it, suggests changes to the code or configuration based on the spec and plan, and you can run implement again on specific tasks to apply the fixes. It's a structured debugging loop until the issue is resolved, always trying to maintain the integrity of the original spec and plan. Now, it's worth mentioning that this whole Spec-Kit driven by folks like Den Delmarsky and John Lamb and heavily influenced by Lamb's earlier work. It's way more than just a tool they've released. It's actually a big research platform for GitHub.
Researching what exactly?
They have these explicit experimental goals they're pushing hard on with this toolkit, really testing the boundaries of what SDD can do.
Like what? What are they trying to prove?
One huge goal is proving technology independence. They're working to really validate the idea that this SDD process, the spec, clarify, plan, implement flow, can work regardless of the specific programming language, framework, or even cloud provider you choose.
If they can prove that, wow, the implications are massive, right?
Yeah.
A team could switch from Java to Go or AWS to Azure without throwing out their entire development methodology.
That's the dream. The spec becomes this powerful abstraction layer that transcends the specific platform underneath.
Okay, what else are they researching?
Second big area is tackling complex enterprise constraints. They want to show this can work for building mission-critical apps where the AI has to handle rules that are often too messy for simple prompts.
What kind of constraints are we talking about?
Real-world stuff. Mandatory compliance with things like GDPR. Strict adherence to a company's internal proprietary design system or CSS framework. Or maybe rules like, you can only use these specific cloud services approved by our security team.
And those would go into the Constitution.
Exactly. They need to be incorporated and actually enforced by the AI throughout the process via that constitution.md.
Makes sense. What's the third area?
User-centric development. They realize not everyone wants the exact same rigid structure all the time, so they want the toolkit to be flexible enough to support different styles.
From the really structured AI native workflow we've been discussing.
All the way to what they actually call vibe coding, like a more free-flowing approach for experienced devs, perhaps. But crucially, even the vibe coding needs to somehow still enforce the core quality standards set out in the Constitution.
So flexibility, but with guardrails. Trying to find that balance.
It's a nod to developer preference, I think, making sure a seasoned dev can quickly iterate on a small part without necessarily rerunning all 6 steps every single time, but ensuring the output still meets the overall governance rules.
They're also looking at creative uses, right?
Yeah, creative and iterative processes. We touched on that parallel implementation idea, using one spec to generate, say, 3 different potential architectures. Lets teams quickly compare the pros and cons of different tech choices before committing.
Rapid prototyping of architectures, essentially.
And finally, they're really pushing on the modernization aspect. Using this structured approach for complex legacy system upgrades that brownfield challenge. Can the AI respect old code conventions while safely introducing new, modern features according to a spec? That's a tough but critical test.
It's actually quite revealing to look at the toolkit's own code composition. It's mostly orchestration stuff, isn't it?
It really is. The breakdown is something like 41% Python, nearly 31% shell scripting, and about 28% PowerShell.
So very little of the kit is about like pre-canned code generation libraries itself.
Exactly. It confirms that the value here isn't in the kit providing the generated code. The value is in the sophisticated structured framework around the AI. It's an orchestration layer designed to take the raw power of these diverse AI models and channel it into a reputable, auditable, governed software development pipeline. Governance is king here. Hashtag, tag, outro.
Okay, let's try and wrap this up. Let's synthesize what we've dug into today. We started with that old world where code was the ultimate truth and specs were, well, kind of disposable.
I've often forgotten, yeah.
Spec-driven development, especially as embodied in this GitHub Spec-Kit, completely flips that. The specification isn't just a document. It becomes the active, executable blueprint. It governs the whole process, right from the abstract idea down to the final mode.
And the key takeaway for you listening, I think, is the sheer value of that imposed structure. The kit gives you this clear roadmap, those 6 steps, the flash commands, and it elevates how you use AI.
It moves beyond just asking an AI to write some code.
Right. It forces you into this governed, multi-step refinement loop. Everything is led by the intent. The what absolutely comes first and controls the how. That structure imposes discipline, both on the developer and, crucially, on the AI agent itself.
It really does change where the high-value work lies for a developer, doesn't it? If AI agents get incredibly good at the implementation part, the actual coding, the routine tasks that implement automates, where does that leave the human?
It pushes the human developer's role entirely up the value stack, away from typing code towards defining the system.
Which leaves us with a pretty provocative thought, maybe something for you to chew on after this. If spec-driven development really takes off, if it successfully automates the how, what becomes the most valuable skill for developers in the future?
Is it going to be deep mastery of a specific language, like knowing all the intricacies of Rust or Go?
Yeah.
Or is it going to be those more abstract architectural, almost legalistic skills? The ability to define the perfect, unambiguous constitution, the skill to ask exactly the right clarifying questions in step 3.
So the future isn't writing the solution, but perfectly articulating the problem and meticulously defining the rules for the AI to follow.
It might just be perfect articulation leading to perfect automation. It's a deep thought to end on.
Indeed it is. Thanks for diving deep with us today.